Let's work through the answers and some of the work for this pre-quiz for Algebra 2. So the topics for this are going to be graphing our radical equations, and then also we're going to work on simplifying. So first of all, this word problem, just to give you the answers if you were to work through this problem. The answer for this first one is going to be 251.7 kilometers per hour. Just a reminder, half a kilometer, just put in 0.5 for x and you could get your answer. This one, got to make sure you take 30 divided by 1,000 because there's 1,000 meters in a kilometer, and that's going to be your x is going to be 0.03. That's what you put in for x there, and if you were to do that, you would get 61, rounded, you'll get 62 kilometers per hour. Okay, and then you can work through thinking through why the velocity changes. Now let's go ahead and do a couple graphs just to practice. This first one, we're going to have a starting point here because it's an even index of a 2. The starting point is going to be on this, we're going to have a negative 4, 1. And then when we do this problem, we'll want to make sure that we set up a table for it. So take the time, I'm going to go ahead and just sketch it here, but you would take the time to put this into your calculator, get out the x's and y's from the graphing calculator table, and then go and plot it. So negative 4, 1 right here, and then the graph would look, because of the 3, it actually arches up pretty significantly once you get that xy table to get the values. Now domain and range, the domain, this is the part I wanted to emphasize. Domain for an even index one, since it starts at this point, where the starting point is and the direction it goes determines the domain. So x is going to be greater than or equal to negative 4. And then the range is going to be y is greater than or equal to that starting point, and it goes up from there, up from 1. If you want to do it in interval notation, it includes these values, so we would go ahead and make this from negative 4, infinity, and this one would be from 1 off to infinity for that one. All right, let's take a look at the this cube root. Again, the 4 in front is going to make it go up more. You want to make sure you do a table from your graphing calculator, but this one's going to have a turning point. So the turning point is going to be, at this case, 6, negative 3. You'll put that turning point in the middle of your table. Get values less than it and values greater than it in order to see that turning point. Whereas the starting point, because that's where it starts and it only goes further than it, you put it at the beginning of your table. Once you graph that 6, negative 3, okay, it's going to be a graph that comes in like this and goes out like that. Okay, again, you get specific x and y values from the graphing calculator. Your domain for this one, again, domain for this odd index, you can put even negatives in for it, so it's going to be all reals. And a reminder, if we do that in interval notation, that's negative infinity to infinity. The range also, this keeps going up. It slows down, but eventually, since it goes off to infinity and it's always increasing, it will also go to all real numbers. It will go off to infinity. So it also is from negative infinity to infinity for the range. Let's simplify this problem down here. My recommendation when you do these is bring the numbers together and then bring the variables together. And for the variables, I would use the exponent form. So for this, I'm going to have the cube root of 5 times the cube root of 25. So bring those two together. And then I'm going to have x to the 4/3. So 4 over 3, that index is the denominator, times x to the 2/3 times x to the 3/3. So bring the x's together and put it into exponent form. This is going to be the cube root of 125. This will be x to the, you add the exponents, 4/3 plus 2/3 plus 3/3. I'll leave it in thirds instead of reducing it down to 1 because I want a common denominator. but when you multiply same base, you add your exponents. Cube root of 125 is just 5. X to the 4 plus 2 plus 3, that gives me 9/3 for the exponent. And now you reduce it, you have 5x to the 3rd power as your final answer for that simplified. All right, and lastly, when we're gonna be doing a problem with the square root in the denominator, we wanna simplify it. When it says no radicals in the denominator, that's what we have to do when we simplify. So you're gonna make this 1 minus the square root of 2, the conjugate of the denominator. So if that's a plus, you make it a minus and do it in the top and bottom. You go ahead and distribute through. 6 times 1 is 6. 6 times the square root of 2 is 6 square roots of 2. All over. Now this, I'm going to treat it like two binomials and double distribute. 1 times 1 is 1. 1 times negative square root of 2 is negative square root of 2. Square root of 2 times 1 is plus square root of 2. And then plus square root of 2 times minus square root of 2 is minus square root of 4, because you can multiply the radicands. 6 minus 6 square roots of 2, all over 1. These two cancel each other out, and then square root of 4 is equal to 2. So we get 6 minus 6 square roots of 2, all over 1 minus 2 is a negative 1. Now that is a correct answer. If you leave it like that, you'll be okay. But just because we've got a 1 down here that's just a negative 1, if I multiply this by negative 1 over negative 1, notice what happens. I get a negative 6 plus 6 square roots of 2 over positive 1. Then we don't have to list it as a fraction anymore. So if you have that, you can leave it like this if you want to. I'll circle this. This is okay and correct, but this gives me something without a fraction. And so in some ways, this is a simpler form for it. So these are the problems for the practice quiz for when we're working on radical simplification and radical graphs.